Hi, and welcome
Hi.
to the third office hours. We've got, again, more good questions.
Let's get right at them.
All right. The first one comes from Voithos, and Voithos is taking CS262 as well with Wes Weimer.
Right.
And he wants, in that class, they talked about finite state machines as
Right.
a representation or the underlying engine for regular expressions.
Mm-hmm.
In our implementation, is that actually what we did, or did we do something different?
That's a great question. So we didn't explicitly show that, but there's a one-to-one correspondence between a regular expression and a finite state machine. And we can post some references, some supplementary material for that. But you can make up a little table of, here's a regular expression, say the alt regular expression, A or B, and then here's a finite state machine. And I guess one way to implement that would be you'd have a start state, you'd have 2 epsilon transitions to the A or a B, and then 2 epsilon transitions coming back. And so any regular expression corresponds one-to-one to a little collection of nodes in the finite state machine. And that means you can go in either direction. So does that mean that we've actually implemented that? Well, it kind of depends on how you look at it. So yes, you could say that we've implemented it because you can show what they look like, but we aren't really creating objects that correspond to these individual states. They're sort of existing ephemerally when we execute the program rather than being defined exactly ahead of time. So in that sense, no. And I guess maybe in the more important sense, the types of manipulations we can do with what we implemented are slightly different than what you would do if you explicitly created these finite state machines, and particularly this transition between deterministic and non-deterministic machines. That's a little hard to do exactly in the representation that we had, although you could do something very much like it by starting to memoize your functions and so on. You could arrive at the same place as you would by doing that transition with the machines.
Great. And if you want an in-depth discussion on finite state machines, you can check out the link below this video to Wes's course.